Hello, welcome everyone to our session of Principia. Before I introduce you to our speaker tonight, Ivan has two short announcements to make. So please, Ivan.
Hello, thank you. The two announcements are this. Our guest, Professor Luis Henrique Dutra, could not come to Principia, but he sent us his text last week. And then his former students, made a reading of the text. Jerzy, Renato, Thiagos, and I, we read it, recorded, and it's now available on YouTube. Of course, it's in Portuguese. There's also a link on GatherTown, but it's all there for you to see. And the second announcement is that tomorrow, after the last conference, which is Fraassen's conference, we'll have a party, online party, Principia online party, on the pub on GatherTown. So please come have a party with us. That's it. Thank you, Jonas.
Good. Then we return now. Let me introduce you to our speaker tonight. It's Otávio Bueno from the University of Miami. Otávio is a very good friend of ours. We always have a lot of fun with his talks. They are always very interesting and raise so many points. We keep on speaking about them for a long time. And tonight, he works developing an empiricist account of science, and that involves also accounting for scientific models, and I guess that's what he will talk about tonight, right, Otávio? So please, yep. It's with you.
All right. Well, thanks, Jonas, for this very kind introduction. And it's always, for me, a real pleasure to be able to come to Principia. And it was actually the first conference I ever attended when I was, just starting my MA program. And I think I attended all of them with the exception of one only. So. And I think it's a phenomenally interesting conference, and it's always a delight to be part of it. Of course, I'm even more impressed and I would like to thank all the organizing committee for the amazing work of getting this through, even in the midst of a pandemic. It's no easy feat. So thanks to Ivan and Jonas and Jerzy and Ioni and all the group. For making sure that the conference is still on and it's as interesting and stimulating as it has always been. Okay, as I like to say, everything was so nice up to this point. Now it's down the hill, right? So what I'll be talking about today is indeed about scientific models. It is indeed part of, as Jonas was saying, part of a development of an empiricist view. And my goal here is to contrast two conceptions. In fact, there are two families of conceptions under the heading of fictionalism about models. The first family of conceptions, I'm going to look at two kind of instances of them that I think raise interesting points, but I'm not persuaded that they go through. And then I'm going to contrast with the second kind of fictionalism about models, another family that I hope can do a little better. So let's see. You'll tell me if it works or not. Okay, so let's get this rolling. So a salient feature of scientific models is that they indeed deliberately misrepresent certain aspects of the phenomena they aim to describe, right? And this is done so that they can better describe and accommodate other aspects of the phenomena, right? This is something that, of course, in the literature has been explored in various and important ways. And of course, in light of that, it's very tempting then to characterize these deliberate falsifications as forms of fiction, right? And that's what, Roman Frigg and and Godfrey-Smith do. Since they, the model seems to involve acts of make-believe, they are common in fictional discourse. Right? So what I want to do today is to resist at least this form of fictionalism about models. Right? I'll try to indicate that it fails to capture properly the roles that the false content played in introducing scientific models played in the practice, right? And the way that how such models could still be explanatory and represent their targets, right? So in a way, it's sort of, I think Margie Morrison raised some of those concerns, and rightly so, I think, in her lovely book, Reconstructing Reality. And I, in many ways, I think of this paper as a sort of homage to her, right? It's sad she's no longer with us here, but it's sort of much of the inspiration here came from her searching critique of some forms of fictionalism about models. So I think, as I'll try also to indicate, I think this sort of first form of fictionalism fails to account for the salient differences between the phenomenology of engaging with fiction and the phenomenology of inferring from models as representational vehicles. So we need, the message of that portion of the talk will be, we need to be careful not to tie too closely fiction and models. If we to connect, of course, there are all kinds of important connections, and I don't want to deny that. But if the connections are tied too tight, we end up losing the content on the science side, the scientific models. So I think that's reason enough for us to try to look for an alternative. So I'm going to contrast these kind of fictionality-based forms of fictionalism about models with another one that resists reifying the models, right, as abstract objects, and tries, within a kind of broadly empiricist view, is to make room for the role that they play in scientific practice, but without tying so closely fiction and the scientific models themselves. Okay, so I think if the second form of fictionalism, I'm going to call inferential fictionalism, is developed properly, I think it should be able to accommodate certain salient features of scientific practice. And I think if that can be worked, there are reasons to favor it. Of course, today I won't be able to offer a full defense of it, but I'll try at least to sketch why I think it's a promising path to take. Okay, so let's start. So one of the main motivations for fictionalism in the context of scientific models has to do, as I mentioned, with the false content that they encode. So one of the questions is how exactly can we specify that false content in a model, right? So a first approach to this issue will involve providing a central role to the imagination of objects and events, right? So in a way, the idea is the objects that are posited in some of those models, false models, are fictional, right? And they are fictional in the sense that we know that they are not true, that the objects do not exist. But if they exist, they will be real concrete objects. That's the basic idea, right? And this is how Peter Godfrey-Smith first worked that out. He says, roughly, we might say that model systems are often treated as imagined concrete things that are imaginary or hypothetical, but which would be concrete if they were real. Metaphysical puzzles abound in this area, but it's common to say that in the case of purely mathematical objects, there is no distinction that can be made between actual and possible existence. Model systems in science, however, are often treated quite differently from this, right? So I'm going to spend most of the time on the first portion of this idea here, right? trying to figure out exactly how these imagined concrete things are supposed to work and how we should make sense of them. But let me just dispose some worries here about the mathematical objects that the Godfrey-Smith considers, right? Because I think the mathematical case, if it's properly understood, is not actually different from the concrete case, right? I think it's perfectly possible to draw the distinction between actual and possible existence in mathematics. How? Well, for example, we may wonder if there are sets that cannot be well ordered, right? Well, the answer is, well, depends, right? If choice holds, the answer is, it should be positive here, not negative. If the axiom of choice holds, the answer is positive. But if it doesn't hold, right, then it's possible that there are known well-ordered sets, right? So in a way, what we are considering here is, the distinction between actual and possible existence has just been drawn in the context of mathematics, right? Namely, it's possible that there are known well-ordered sets, right? And of course, if the axiom of choice exists, well, then all sets are well-ordered. So you can still draw a distinction between possible existence and actual existence. Of course, in order to do that, we need to acknowledge that mathematical axioms can be revised, right? And of course, I think this is just a fact about mathematics, right? But it's the idea that mathematics has an absolute character, right? That I think pushes us to think that, look, if something is possible in mathematics, it has to exist. So you cannot have an actual, a distinction between actual and merely possible existence in mathematics, right? But I don't think there is no reason to think that that's the case, namely that the axioms cannot be revised, right? The mathematical universe, in fact, becomes far more interesting to be explored if the axioms are revised, right? So in that sense, the answers to mathematical problems are always relative. The relative to the axiom in question, and relative to those things, certain things will be actual, other things will be merely possible, right? And that's how we can draw those distinctions. All right, this is just a little quibble here, but just to complain about a sort of a too rigid understanding of mathematics that seems to be motivating in part some of the considerations of Godfrey-Smith. Now, returning to the meat of the discussion. Godfrey-Smith tells us, I take it at face value, the fact that modelers often take themselves to be describing imaginary biological populations, imaginary neural networks, or imaginary economies. An imaginary population is something that, if it was real, would be a flesh and blood population, not a mathematical object. I think this is the crucial move of the proposal, right? Models are being introduced as describing imaginary objects, right? Imaginary populations, imaginary neural networks, economies, and so on. Objects that would be concrete if they existed. That's the other important feature, right? They're not abstract objects, right? They're supposedly concrete things. If they existed, they would be just like the objects that we inhabit our own world. And he continues, although these imagined entities are puzzling, I suggest that at least much of the time, they might be treated as similar to something that we are all familiar with, the imagined objects of literary fiction. You have in mind entities like Sherlock Holmes's London, the Tolkien's Middle-earth. These are imaginary things that we can somehow talk about in a fairly constrained and often communal way, right? So this is the fictionalism bit, right? Is that this analogy between objects that are posited in a scientific model and objects posited in a literary fiction that Godfrey-Smith wants to explore. On the view I'm developing, the model systems of science often work similarly to these familiar fictions. The model systems of science will often be described in mathematical terms. We could do the same to Middle-earth. But they are not just mathematical objects. So here, Godfrey-Smith is trying to resist the idea that, well, we can just think about those objects in a model as abstract objects, right? They don't exist in the physical world. They're just abstract entities. And he wants to say, no, that's not the proper way of thinking about that, right? They are concrete in the sense that had they existed, they would be spatial temporal concrete things because they are part of what we are trying to describe with the scientific models, right? Now, this is his take, right? Of course, then he acknowledges that, well, of course, we need to develop exactly what is the metaphysics underlying these objects, these fictional objects that figure in scientific models. He doesn't do that, but that's something that is done by Roman Frigg using Kendall Walton's, pretense theory of fiction, right? So this is the second leg of these, this first form of fictionalism, right? That I call the fictionalism, right? Because a crucial role is played here by the pretense operation and the fictionality or the imaginary content of the objects in a model, right? And Frigg developed further this connection between models and fiction by exploring Kendall Walton's well-known theory of make-believe, right? His pretense theory of fiction. Now, according to this theory, a variety of props, right? Novels, motion pictures, paintings, plays, children's games. These props can be used to prompt participants to imagine various situations. And in this way, they generate games of make-believe. So it's just like when a kid is playing with a hobby horse, right? And using that a prompt to imagine that she is just riding a horse in the plains in the border of the U.S. and Mexico. So the idea here is that these are props for imagination, right? We don't take them to exist. The props do, but not the imagined objects, right? And as Frigg says, this game can be played by a single player when reading the work, or by a group when someone tells the story to others, right? And then he focuses his discussion for simplicity on the case of literature, right? So part of the story now is then to tell, okay, how can we talk about fictional truths, right? And well, they're generated by props based on principles of generation, right? According to Walton, there are primary truths generated directly from the principles, right? Those are the things that in the story would be explicitly stated. Sherlock Holmes is a detective, right? Lives in Baker Street, has a friend called Watson, and so on. And there are implied truths, right? Which result from the application of some rules of inference. So you have to do some kind of inferential work in order to get to them. They're not immediately, stated, but you can get to them indirectly, right? So, for example, in Albert Camus, The Stranger, Morrison killed a man in Algiers, right? That's a primary truth, right? Now, the fact that he then faces the absurdity of existence as he waits for his execution, that's what goes on in the second half of the novel, it's arguably an implied truth. It's not stated as such, but you can get a sense that that's something that the novel is conveying indirectly by focusing on some inferences from Morrison's behavior and his thinking. Now, how can then the pretense theory help with the ontology of models? What Roman tells us is that, well, model systems usually are presented to us by way of descriptions. And these descriptions should be understood as props in games of make-believe, right? So we can then specify the conditions under which a statement, such as Morrison killed a man, is fictional in a given work. So here's how we do that. P, right, the state is fictional in a work, W, if the prop given the work, together with the principles of the work of generation, prescribes P, the sentence in question, to be imagined, right? Now, this is just a sort of a fancy way to say something very straightforward in a way, right? That something is fictional if you just, it's the case given what the story prompts us to consider, right? And then the notion of truth in a fiction can be formulated straightforwardly, right? See, if P is fictional in a work, in a certain work, right? The statement P is fictional in a work W is actually true. So, for example, it's true that Morrison killed a man in The Stranger, right? So the principles of generation, the descriptions offered in the novel, prescribe that this situation be imagined, right? As you read the novel, you read the moment in which Morrison, bored, with life in a sunny day, goes there and just shoot the man once he sees the man with a knife approaching him. So you're reading a novel, you're imagining this situation prompt by the description offering in the work. Okay, I think so far this is all fairly standard. And then the work that the Frigg does is to extend that to models, right? This analysis of truth in fiction carries over to model systems one-to-one, simply by replacing P by a claim about the model, W by the description of the model system, and the W principles, the principle of the work, principle of generation of the work, by laws and principles assumed to be at work in the model. For instance, the solar system stable is true in the Newtonian model of the solar system, if and only if the description of the system, together with the laws and principles assumed to hold in the system, the laws of classical mechanics, the law of gravity, and some general assumptions about physical objects, imply that this is the case. So basically what we have here is, once we laid out Walton's pretense account, right? Under what conditions something is true in a fiction. We can simply, by replacing the principles of generation of the work by the appropriate laws and principles, and replacing the work by the model, we can just simply have a direct description of the conditions under which a certain statement is true in a model, right? The solar system is stable is true in the Newtonian model. Moreover, Frigg also argues for there is an important benefit in going through this route, because then we can offer also a story about how we can get to know the models, right? And what they entail. So he tells us, this take on truth also provides us with an answer to the question about the epistemology of models. We investigate a model by finding out what follows from the primary truths of the model and the rules of indirect generation. This seems to be both plausible and in line with the scientific practice, because of a good deal of the work the scientists do with models can accurately be described as studying consequences of the basic assumptions of the model. So the idea is, look, if we adopt Walton's pretense theory, you're able to specify in what sense fictional objects are part of a scientific model, in what sense there are truths in this model, how we can get to know what holds in this model, right? So there are epistemological and metaphysical advantages by doing that, right? And so the talk that Godfrey-Smith initiated, talking about imagine concrete objects, right, as what we are doing when we're considering objects in a model, is fleshed out here via Frigg's use of Walton's account. It's fleshed out as just being those things that hold in the fiction, right? So, and the things that hold in the fiction are those that ultimately would follow from the models, given the principles of generation that the model provides, right? So that's the idea, right? So I call this a fictionality account of fiction because it tries to connect directly, right? So you look at objects in a model are fictional exactly in the sense that Morrison, Sherlock Holmes, are fictional objects, right? The only difference is one might be a point particle in a Newtonian model, and the other is a character in a story. But they are entirely analogous. So that's the idea. So there's a close tie between the two, models and fiction. Okay. Now, the idea, of course, there are interesting things going on with the idea of connecting models and fiction. And I think there is indeed a lot of fiction that goes in models. And in some of my work, I have explored those connections. And I think there are those connections. But I don't think that the connections should be so tight as the ones that the fictionality account of models offers. So, on the surface, it may seem that the application of the pretense theory to scientific models provides just what we want, right? But I want to say that appearances here are actually deceptive, right? First, I want to say that the pretense theory is entirely unnecessary to understand under what conditions the solar system is stable in the Newtonian model of the system, right? So, because it simply follows from the model, together with the relevant laws and principles, that the solar system is stable, right? So, in a way, we are adding here a certain metaphysical description to the model by going via the pretense route of something that is actually unnecessary, just to understand the content of the Newtonian model, right? Of course, the idea would be to say, yeah, but look, there are no forces in the way the Newtonian model stipulates, so it better be fictional, right? So yeah, well, the model is false, and we know that, and we don't need, in order to specify that, we don't need to move through the pretense theory, right? To imagine any circumstance prompt by props is just not part of the consideration, right? What we do in order to figure out whether the solar system is stable or not in the Newtonian model, it's something quite different, right? We want to know whether that follows or not from the model, right? And that's what we need to establish. So it's not surprising that there's no reference to props, imagination, or fiction. And none of those, no reference to those will figure in the conclusion about the stability of the system, right? So the pretense theory necessarily adds a layer of artificiality to one's engagement with fiction. In fact, that's what I want to say about the pretense account of fiction, right? That it unnecessarily adds a kind of an artificial mediation by the props as something that will allow us then to imagine the content. And I think as a pretense, right? So I don't think that that's the proper phenomenology of our engagement with fiction, right? So if you think about when you're reading a novel and you're lost in the content of the novel and the way that the novel is working out, you're not considering at that point that, well, you have a book on your hands, you're staring at pieces of words and read tracks as the content, right? So, and you're not considering, well, I'm pretending that those things are going on in the fiction, right? You simply are completely immersed in it, right? Just as a Newtonian physicist is completely immersed in the picture of his or her model, right? And trying to figure out what follows from that. So they are assuming the principles of the model and trying to say, okay, I want to know what follows from those principles, right? So there's no fictionality involved in the sense that you are pretending to do something. You just trying to figure out what follows there, right? So my worry here is that the pretense theory had a sort of an artificial layer to our engagement with fiction, and would then also would add an artificial layer to the scientific models, right? Which now need to be thought as particular prompts, right? Rather than offering principles for us to reason about the phenomena, a question, which is, in fact, what we want the models to do. So I want to say that rather than imagination, it's inference that plays the key role here, right? What follows or not follows from the model, together with the relevant principles and laws, well, if there are any laws, is what matters, right? It's not what we imagine, but it is what we can derive, right? What follows. Now you may say, oh, come on, Otávio, don't be so picky. What's the difference? Well, it's a huge difference, right? Because imagination, I think, doesn't even, as I'm going to return in a moment to that, imagination doesn't even put us in the right ballpark when you're considering scientific models. And I'm going to return to that point in a moment, right? I think similar concerns here emerge on the alleged epistemological benefits of thinking about scientific models in terms of prompts for imagination, right? Because in order to determine what a model conveys, what we need to do is to figure out what follows from the model, right? So it's a process of drawing conclusions from the model. It's an inferential process. And this is going to pave the way in the second half of the talk, when I consider the inferentialism, right? So these are the considerations of like that are what sort of thing motivates us to think about the role of those models differently from the fictionality of what the fictionality account is inviting us to do. Now, Frigg tells us, we investigate a model by finding out what follows from the primary truths of the model and the rules of indirect generation, right? That's a passage I quoted a minute ago. Now, I think what is going on here is basically a change of terminology, right? Instead of talking about basic principles of the model in the way that scientists regularly talk about, we're invited to talk about primary truths, right, of a fiction. Instead of talking about consequences from the model, as scientists talk about, we're invited to consider rules of indirect generation, because those are the framework, parts of the framework of the pretense theory. So in a way, okay, we have here a translation scheme, right? But why do we need the translation if we already understand well the way in which consequence operates, the way in which principles specify the content of a model? Of course, to the extent that those things are clearly worked out, right? So, of course, there are all kinds of puzzles there, but it's not clear to me that those puzzles are going to be resolved by recasting them in terms of truths in a fiction. But I don't think the worry here is just a terminological one, right? Because more importantly, I think a questionable layer of interpretation is also added to scientific practice, given the pretense account of the concepts in question. Right? We need now to understand models as props for imagination. Right? We need to emphasize imagination as the key component to get us access to the relevant contents. Right? And I don't think that that's what's going on. Right? After all, models seems to play a very different role in scientific practice as items that encode information about their targets. We may imagine all kinds of things based on a model, but what is crucial is what we can infer from it, right? That what follows from the model to the best of our abilities. Often it's complicated due to computational intractability to figure out what follows from the model or not. But that's, again, is an emphasis that what is at issue here is not what we can imagine. What is an issue is what we can infer, right? And the limits of what we can or cannot infer from the model. That's where the action is, right? Also, as I mentioned a minute ago, I don't think imagination is even on the right thing, the right faculty for us to be considering here, right? By focusing on the pretense account, we are forced to play a key role, assign a key role to imagination, as imagine concrete objects. Props from imagination that the models are supposed to be. Now, the worry here is the following. Imagination, as we all know, is not factive, right? We can imagine all kinds of falsities, right? Perhaps we can even imagine impossible things. But knowledge, to the extent that it's something that we aspire in science, don't think we aspire to that, but to the extent that we do, knowledge is factive, right? So if we know that P, then P is the case. So the worry here is if models are tied to a known faculty of imagination, how can we then explain the way in which models provide us with knowledge, right? Assuming for the sake of argument that they do, right? So, and again, I think we're just by emphasizing imagination, we make it very hard to understand how we can get some knowledge of the world when we're using falsities in a model, right? So, and because, you know, we can imagine anything. So just saying, look, I imagine this. Sure. How could then, why would that just give us any reason to believe that that's the case, right? So I think imagination in a way, in this particular context, it's very confusing, right? It doesn't help. Of course, imagination plays all kinds of important roles in generating ideas, right? We have to have imagination in order to pursue possibilities, but they themselves, the imagination itself, doesn't have the proper epistemological oomph to cash out any alleged epistemological gains the models may have. Now, recall that Frigg tells us a good deal of the work that scientists do with models can accurately be described as studying consequences of the basic assumptions of the model. Now, I think this is exactly right? And I think this is exactly what scientists are doing, right? Noting, studying consequences of the basic assumptions of the model. But note that this is in order to state what is right about the role and function of models. We don't need the pretense theory, right, to reach the conclusion. We can do that quite independently. What we need is a notion of consequence. We need, the notion of inference, right? You need the notion of assumption of a model, principles of the model. These are the things that scientists are actually operating with. And if we have any hope at illuminating aspects of scientific practice, we better understand in their own terms what scientists are doing. So that's why I think the artificiality invoked in the pretense account would just take us miles away from where we want to be. Okay, so that's one concern of particularly the use of pretense theory, right? Let me now consider more directly Peter Godfrey-Smith specific points about the imagined concrete objects approach to the fictionality of scientific models, right? Even here, I think there are several difficulties with it. First, I think some imagined concrete objects are just flat out impossible, right? So for example, it's unclear how certain imagined concrete objects could exist, since they would violate empirical information about the world, right? At least if we assume that the information we have about the world is accurate, these objects simply cannot be what these imagined concrete acts tell us that they are, right? So for example, no concrete object can possibly have its entire mass in a single dimensionless point, right? No concrete object can be a point particle, right? I think that's just a flat out impossibility, right? No such object can possibly exist, given accepted information about the physical world, right? Given that, we need some mass in order to have motion in space. You need, then the mass cannot be dimensionless, right? The force you need to act on it. So we simply cannot have a concrete object that is actually a point particle. Now, so if we are when we're considering a model in Newtonian mechanics, we are imagining a concrete object, right? A Newtonian particle as a point particle. If that's what we're doing, right, we actually will have to be imagining something impossible if you're taking that particle to be a concrete object, right? Because you simply cannot have both things. Okay, second concern. Imagine concrete objects in fiction are fundamentally different from concrete objects in the world. And why is that, right? So I think a salient feature of fictional objects is their inherent incompleteness, right? Their partiality. And that's something, again, I'm going to return to the second half of the talk. The properties that the object has are those that are explicitly given to them in the fiction, or that follows from those properties that they have. The remaining properties, I think, are just left open, right? So you may wonder, what's the color of Sherlock Holmes' socks, right? If, assuming you were wearing socks, when he solved the Moriarty case, right? The issue is simply undecided, right? There's no fact of the matter to settle it, at least to the best of my knowledge. So nowhere Conan Doyle specified that in the stories. There's nothing that's said in the story that forces in one way or another. Given that all the content we have about Sherlock Holmes is what is just said in the story or what follows from what is said in the story, and nothing is said about those things, I think the proper conclusion here is, well, this is just left open. There's no fact of the matter here, right? So it can be any color, right? But we cannot possibly know, right? So it's left open. I will return to that impartiality. I think that's a crucial feature of fictional objects. Now, in contrast, for concrete objects and people in the world, the issue is decided, right? Given the completeness of their properties, right? So we all, have all the properties or do not have the properties that we have, right? Of course, so either we are wearing socks or not, right? If we are, these socks will have some particular color or not. We may not know what the color is. We may disagree about the shade of the color and all kinds of things, but the completeness is just part of being concrete, right? It's just a part of being known fictional, right? So it's in that sense that I think imagined concrete objects are fundamentally different from concrete objects in the world, right? The fictional are incomplete. The concrete objects in the world are not. So again, to just lump them together in the way that we are invited to do by this account of models, I think just invites confusion. Now, to some extent, I think Godfrey-Smith seems to grant this point, right? After all, he tells us, when most people read Lord of the Rings, before the films were made, they imagined the orcs of the book in a very schematic way. Few would have bothered to work out how many toes an orc has. Peter Jackson, the director of the films, had to imagine his orcs with much more specificity than most of us did. He had to specify the number of toes on an orc. And of course, if you watch the film, you would have at least a sense of how in the film this gets answered. Now, I think what's at issue here is actually something a little different, right? It's the difference between linguistic and pictorial representation, right? So it's not the issue of the completeness per se, I think. So in the novel, the orcs are described linguistically, and as such, they can be maximally under-described, right? If nowhere in the novel is it specified the number of toes that an orc has, the issue is simply left open. And you can do that in a linguistic representation, right? You can be maximally under-specific about something. So in the films, however, which depend on a pictorial representation, no such under-specification is possible, right? If the front of the naked foot of an orc is being shown in a close-up in the film, one will need to show his toe, right? Assuming he has one, right? There's no option here, right? So what's operating here is this difference between the content of a statement such as the cat is on the mat and an image of a cat on a mat, right? The former, the statement the cat is on a mat, can be true with no further specification about the cat or the mat, right? So if the cat is on the mat is true, well, that's the, like Snow is white. These are the primary philosophical statements, right? So, well, the cat is on the mat is true, provided that the cat is on the mat. I don't need to say anything about how large the cat is, what color he has, how exactly it was spread on the mat, how was the mat, none of that, because a linguistic representation doesn't require that. Now, pictorial representations are different. They would require that you settle all of those things, otherwise you'll not be able to recognize that what you have in front of you is a cat or a mat, right? So I want to say that, this image here that I just showed you has the content that the cat is on the mat, right? But it also needs to specify the cat in all kinds of ways because it's a pictorial representation. And so now I settle all kinds of issues: the color of the cat, whether it's sleeping or not, how it's on the mat, what is the color of the mat, how is the mat, and so on. Right? So what is at issue here then is it's the kinds of representation that are involved: linguistic representation and pictorial representation. Right. So in just engaging with the linguistic representation, Tolkien didn't have to settle the issue about the toes of an orc. Right. In the film, this being pictorial, some of those things will have to be settled. Now, of course, that doesn't mean that what's settled in the film would settle in the story, in the literary story, right? Because now we need a theory about how to connect these different kinds of fictions, right? Of course, that would be a topic for another day. What matters for us here, however, is that provided that the relevant scientific models represent linguistically rather than pictorially, right, the corresponding under-specification can be achieved without problem, right? A model will leave lots of things under-specified. And in fact, that's why often we need interpretations. So we're going to add content that was left unspecified in the model, and often have more concrete, as it were, in square code models, right? Those that provide further content to try to work out certain things that the larger theory left completely unsaid, right? And we can perfectly accommodate that with that salient fact about linguistic representation. All right, third concern about the imagine objects approach. I think the ontological status of fictional objects and concrete imagined objects in models is importantly different. Right? So fictional objects are known not to exist and have not been posited as possibly existing, right? So it's fiction, right? So if a fictional character is introduced, it's not introduced with the hope that one day what is described in the fiction becomes reality, right? Even if it does, right, by sheer coincidence, you cannot say, oh, what's described in there now it's true of, because what's described there in the fiction just describe the world of the fiction, and that's that, right? Sherlock Holmes is posited as a fictional character, even though he is within the fiction posited as a man. That man being fictional cannot possibly exist. At least that's a reasonable account of fiction, right? So Kripke, for example, would hold that view. I'm not an essentialist, so I don't want to buy into the entire picture on that. But it seems to me that fictional objects are posited in a fundamentally special way, right? They are posited as not existing, right? Of course, sometimes interesting fiction will blur, right? An interesting way will try to blur the divide between fiction and reality. But again, that's just part of the fiction. Someone who, in a visit to London, goes to Baker Street, seriously looking for the place where Sherlock Holmes lived, I think is unfortunately confused, right? So it's fiction and reality don't just connect in that way, right? So in contrast, imagined concrete objects in scientific models are posited as possibly existing, right? They would be flesh and blood objects if they existed. In fact, that's the whole idea behind Godfrey-Smith approach, right? So you're invited to think them as indeed possibly existing. And I don't think we can do that with fictional objects, however. All right, finally, our epistemic attitude toward fictional objects and imagined concrete objects, I think it's also fundamentally different, right? To know the properties of fictional objects, we just need to follow the story in which the deeds of these characters are presented, right? Amy Thomason, in her book on metaphysics and fiction, beautifully, I think, portrays that. And you can do that without a heavy-duty account of a pretense theory in the way that Walton did. I think there are much lighter ways of doing or spelling that out without bringing in the whole pretense machinery, right? So to know the properties of imagined concrete objects, in contrast, however, we need to consider the world and gather information about them, right? Need to figure out, okay, what are the things going on in reality? Now, the models may play some role in this process. We might be guided by bits of information in the way that the objects are being characterized, but that cannot be the entire story, right? Otherwise, it would be unclear how the models could be connected with the world, right? And I think one of the troubles for that form of fictionalism is to detach too much the fictional, to connect too closely the imaginary fictional objects and the objects in a model. Because we want, even though the objects in the model do not exist in the way they are described in the model, we want to be able to connect, even to specify in which ways had things been different than the model would actually be true of the world, right? So in many cases, that's how we learn from the model. So I think for these reasons, I think there are serious concerns about the form of fictionalism, about models that connect scientific models and fiction so directly. So in the remaining of the talk, I want just to highlight a different way of proceeding, a different way of thinking about those issues, right? And as you can gather from what I said so far, inference will play an important role in this form of fictionalism here, right? Again, just as with the fictionality approach, it's actually a family of views, right? So, you have the considerations that Godfrey-Smith offer. We have Frigg's use of Walton's, and there are different variations you can make on that. Here also, when I'm calling inferential fictionalism, also would have different formulations associated with it, right? But what I want to do is just to contrast, right, this family of views, this fictionality-based fictionalism that we discussed, with a different sort of fictionalism about models, right? That will resist this idea that it's the fictionality of the posited objects that makes a scientific model fictional, right? I think a model can be fictional in a different way, right? As I said, an important part of fiction is its incompleteness, its partiality. And I want to explore that, right? I think a model can be fictional because it's partial. It provides only a partial description of the phenomenon under consideration. It does not provide a full story, right? So it leaves out things that if you want a full story, we will need to settle, but it doesn't. And because the world will have those things, and we just don't know exactly how they operate, is that what we have here with the model is just fictional. It's partial, right? So in that sense, models are used as devices to draw inferences about the world. That's why we need them. They're inferential procedures, right? As I already tried to indicate in my worries with the fictionality approach, right? The resulting account, I think, can then be called inferential fictionalism because it emphasizes this inferential role. Now, let me mention briefly 3 different ways of being an inferential fictionalist. And then I'm going to pick up one of them and say a little more in the time that I have, right? The good thing is that they are all familiar in different degrees from the literature. Here's one way, right, that you can be an inferential fictionalist. You can be a constructive empiricist, right? You can say, look, scientific theories understood as a family of models need not be true to be good, provided that they are empirically adequate. That is, they are true regarding the observable. So we're going to constrain around the partiality. What are the things? Well, we're going to just describe, hopefully accurately, the observable parts, right? The unobservable parts, well, we better be agnostic. We don't know how to settle those things. Now, this is a form of fictionalism, right? It's taking models as offering just a partial story, right? They don't provide the full story about the way the world is, right? They provide a story, hopefully a right story, about one portion of the world, the portion that we can observe, right? That's constructive empiricism. Now, on this picture then, a scientific model need not account for every aspect of the world, right? Only a portion of it, the observable part, needs to be accommodated, right? So that's the partiality bit. Now, a different way, a different kind of fictionalism will be structural empiricism, right? A view that I've sort of tried to work out over the years, right? Scientific theories understood as a family of models need not be true to be good, provided that they are quasi-true or partially true. That is, true relative to accepted information in the relevant domain of inquiry. So the idea is, and of course, this is the idea of partial truth or quasi-truth comes from the work of Newton da Costa and Stephen French. And I try to give a sort of an anti-realist twist or perverse twist, as Stephen would think, on that idea. Right? The idea is, well, if a model is partially true, it captures some portion of the world, and what it says about that portion, at least, is could be extended in some way to the larger portion of reality that it does not describe. So it's not ruled out, right, completely by what's accepted in the relevant domain. Important, it's accepted, right? We can change what is accepted there, and then we're going to renegotiate what is partially true. Again, because, and then of course, I'll tell a whole story about what are those things that are partially true, right? How to connect what's partially true with what is observable in some sense. So there are all kinds of details that we'll need to, and that some of which, I discussed elsewhere. But what matters here for us is note that it's that partiality. Again, it's not the full truth that a model gives us, it's a partial one. And it's that partiality that helps us understand in what sense the model is fictional. It doesn't give you the full picture, right? Now, a third way, and I'm sure we'll hear in a second from Elgin herself whether that's way, it's adequate or not, would be to think about, not in terms of partial truth, but in terms of true enough, right? Scientific models need not be true to be good, provided that they are true enough. That is, despite being inaccurate, the models exemplify features they share with their targets, and thereby afford epistemic access to aspects of their targets that are otherwise overshadowed or underemphasized. Now, I'm not sure whether Kate would be happy with fictionalism. She, of course, argued for some shared epistemic practices that the sciences and the arts have in her Considered Judgment book, right? But in any case, I would love to welcome her to the club of the inferential fictionalists, right? I'll return to that in a moment. Now, these are three ways, right? So let me say a little bit about the middle one. Of course, Elgin will be able to speak for herself, and Bas on the constructive empiricist side, right? But before that, just to highlight, right, the idea here, and that's why I think it's a family of views, instead of insisting that scientific models are fictional because they are imagined concrete things or their content emerged from props to imagination, we can think of models as devices that encode partial information about the world. And it's that sense that they are fictional. Models can be empirically adequate and encode information about the observable objects, processes, and events. Models can be partially true and encode information about their target domain by extending information that is accepted about the domain. And not all such extensions will be true. And I'll say more about that in a moment. Or models can be true enough and encode information about their targets by exemplifying features they share with their targets. And so those, I think these are three ways in which we have a form of partiality being recognized as key in the way that the models operate. And what's important, I think, again, why all these three proposals share what they share in common also is the idea that, well, models are about the world. Because after all, is the target. We are interested in making sense of the world, right? Or the portions of the world that we're trying to understand. So in that sense, I think it's important, as opposed to the fictionality approach that just shift models all the way to fiction. I think we need to move the models back to the world, because that's what will allow models to play the inferential role that in scientific practice they do play. So let me say a little bit more about the middle proposal, right? In terms of partial truth, right? So on that version of inferential fictionalism, I'm in favor in terms of partial truth and partial structures. There's no need to establish a direct link between models and fictions, right? And as I argued in the first half of the talk, I think such a link in the case of scientific models is seriously problematic. So a partial structure is what? It's a structure that has a certain domain of objects. These are the objects of investigation, and a family of partial relations among these objects. What are those partial relations? Right, relations are partial in that they have three components. An R1 component, those are relations we know are known to hold, known to hold in the domain. R2 are relations known not to hold. And R3 are relations that are not known whether they hold or not. Again, sorry about those typos here. Now, what's important here is, of course, if R3 is empty, we just have a standard relation, right? So relations that can be identified with the R1 relations. Those are known to hold. So the idea of a partial relation is it encodes some of the partiality of the information, right? Some of the things that we just don't know about the objects we are investigating. A sentence is then partially true in a partial structure that encodes information about the domain under investigation. If it's true in a full structure, right? That full structure that, if there is a full structure in which it's true, right? So the idea would be, well, the partial structure would encode some information that is accepted in the relevant domain, and we could extend that information by suitably adjusting the third component to the first or the second to a full information, right? So if we can do that, then the sentence is partially true. Right. So the idea is, if you think about Newtonian physics, well, it's not true, right? The world is not, there's no such a thing as gravity, as a force acting among objects in the way the Newtonian physics will require. But it does capture something right. That's the idea, right? There are portions of the world that behave in ways that are in accordance with the theory. Right, so we can describe objects that are not subject to intense gravitational fields, whose speed is not close to the speed of light. We can describe them fairly accurate within the context of Newtonian physics. So in that sense, they are partially true. They describe partially some domain of objects, right? But they're not true, right? So a partially true sentence, although false, may be true, right? So in the sense that the world could have been that way, right? And of course, we can even, by adjusting and changing the parameters of the description, the world could be shifted, right? So instead of having the forces and the way acting in the Newtonian way, we could have gravity as part of the curvature of space-time. And then we get a full picture that it's in which the sentence will turn out to be true with the proper corrections, right? Now,
Otávio, sorry to interrupt you. Just to warn you that a bit more than 1 hour has already passed.
Okay, yeah, so I'm almost done here, right? So I'll just give an example here to illustrate how this is supposed to work, right? Now, this is a description of a physics in a physics book. In fact, Roman gives this example here. So in physics, a model is a simplified version of a physical system that would be too complicated to study in detail. Suppose we want to analyze the motion of a baseball thrown through the air. How complicated is this problem? The ball is neither perfectly spherical nor perfectly rigid. It has raised seams. It spins as it moves through the air. Wind and air resistance influence the motion. The earth rotates beneath it. The ball's weight varies a little as its distance from the earth changes, and so on. If we try to include all these things, the analysis gets hopelessly complicated. Instead, we invent a simplified version of the problem. We neglect the size and shape of the ball by representing it as a point object or particle. We neglect air resistance by making the ball move in a vacuum. We forget about the Earth's rotation, and we make the weight a constant. Now we have a problem that is simple enough to deal with. Now, what we have here, I want to say, is the specification of a partial structure in which known information about the domain is deliberately ignored, right? Such as air resistance, the imperfection of the ball surface, and its spinning, the Earth's rotation, and so on. We shift relations from what is known to hold to things that are now assumed not to be known, right? So we just ignore those things for the purposes of setting up the model, right? By representing the ball as a point particle moving in the vacuum with constant weight, we turn an otherwise computationally intractable problem into a tractable one, right? So the description of the situation is strictly speaking false, right? Because there are no object in the world as we know it that would behave in that way, because there is vacuum, there's no vacuum, there is air resistance, there is friction, and so on, right? So the description is false, but it's partially true, right? In what sense? If the ball were a point particle moving in the vacuum with constant weight, its trajectory would be just like the one described in the model, right? It would hold, given the specification of the partial relations given in the model, right? So it's partially true, right? And this is something we can infer from the model. In fact, we set up the model exactly so that we can get some information about that, and then make inferences from the relevant model. Now, then, by adding in stages, air resistance, the ball's variable weight, its spinning, we slowly approximates the model to the situation that actually holds in the world. What we're doing there, we're shifting relations, right? From the R3 slowly to R1 and trying to get the model as close as we can, computationally tractability allowing, as close as we can to the world. Now, here I think Elgin can also be very helpful with her idea of felicitous falsehoods. She tells us, here's where felicitous falsehoods enter the picture. The utility of such a falsehood is plain. It's sometimes inconvenient, difficult, or even impossible to bring it about that the phenomena exemplify all and only the features that interest us. DNA molecules are very small, charged pions are short-lived. If we introduce a falsehood that exemplifies those features, a bigger, longer-lasting model, for example, we can highlight them and display their significance for the understanding of the phenomenon in question. I think Elgin is exactly right here, right? And what I would do is I would describe her felicitous falsehoods precisely in terms of shifts of relations of a partial structure in the way we just accounted for, right? So when she's talking about we are interested in phenomenon in phenomenon that may turn out to be too difficult, inconvenient, or impossible to bring about. Well, that's where we introduce felicitous falsehood. That's where we shift things from R1 to R3 in my vocabulary in terms of the partial structures. That's where we set up a partial structure, right? In order then to understand how a simplified model can actually tell us something about the world rather than about fiction. So to conclude, fictionalism about scientific models, I think, is a very tempting idea, and there is something importantly right about it. We need, however, to be careful about how the idea is developed. If connections between fiction and scientific models are too tight, the view quickly becomes implausible and unworkable. But if a gentler understanding of fiction is invoked in terms of partiality, in the way I suggest, I think fictionalism becomes a far more interesting and hopefully defensible proposal. I suggest here that understood in terms of partial structures and partial truth, inferential fictionalism provides at least a prima facie sensible account of scientific models. Far more needs to be said about all of these, of course, but at least I think this is a line worth pursuing. Thank you very much.
Well, thank you, Otávio. Thank you, everyone. People, please, if you have questions, type Q in our chat, then Otávio will answer them. So we already have a question by Maria. Please, Maria.
Thank you.
Also, sorry, Maria. Given that we are a bit ahead of our time, I ask everyone to make questions rather objectively. Okay.
Thank you. Good night. Thank you, Otávio. Sorry, I lost the screen of Otávio here. Sorry. I want to see him. Okay.
Well, try the gallery view on the top right-hand corner.
Yes, I am. I am in the gallery view already. But okay. I can see you now.
Okay.
So I want to think a little more about this thing of consider some characteristics of models as falsities. I think that could be a mistake. Name it as falsities. I never think about this before, but I remind my classes about Husserl, in which the professor take a chair and put in the front of the class, and made us think that any one of us already can see the chair in their complete, but just a part of that chair. So we assumed the rest of the chair because that was plausible, you know? So if we can think that this is a way like of a natural way to think, like filling the gaps, I wonder if we should to name falsities as falsities, those things that we complete in the models. At the end, we are putting our best knowledge about some things to complete those things in the nature that we don't know. So right. I don't think that those are falsities. And even more, you said that in physics, I think that was a quote, but in physics, the model is a kind of abbreviation of something more complex. So I am assumed that you think, as well as me, that this that is not a mistake complete the model. So I want to hear something more about that, because I don't know, for me it's not a falsity, you know. For me, there are nothing false in the models. We are trying to do something, and is the best that we have. So I want to hear more.
Good. No, that's a fair point, right? It's just that often models are there because the world is too complicated. There are too many things going on for us to be able to have a good handle on. So the model, in distorting certain things, ignoring others, makes it feasible for us to get a handle on the phenomena. But in doing that, some of them turn out to be false, right? but they're not completely false in the sense that if some portions of them are correct, right, in some respect, right, because otherwise they would be completely disconnected from the world. And that's, and I think that's the part where if we consider them to be fictional, we will be led fictional in the sense, in the fictionality view that I discussed earlier in the paper, that will be led to go, right? So, and so Newtonian physics and its models are false, right? But there is something right about that. So that's where the idea of a partial truth will come in, right? You acknowledge that there is some portion of reality that's right, but even though there are lots of things that the model does not quite get it, right? So now, of course, the analogy with perception, with the Husserl example you mentioned, is delicate because, of course, perception is different. Perception is not, at least one view of perception, a kind of direct realist view of perception. It's not a matter of having a model, right? We just open your eyes and you see the world, right? And so I see the chair. And what, in order for me to see that chair in the world that we live in, it means I cannot see the back of the chair when I'm seeing its front, right? Because for me to be able to do that, the chair will have to be perfectly transparent. And then I would not be able to see the chair at all, right? So, so if you understand, perception as a direct realist would have it, then sure, the perception is always perspective. There are certain things we see, certain things we won't, right? But it's not a matter of having a model, right? It is at least once you learn how to use your eyes. It's just a matter of collecting the information you're getting through your senses. Of course, there's a lot more to be said about all of those things, right? But I hope that at least that's a start.
Thank you for your talk. It was very inspiring, as usual. Thank you.
Thank you.
Thank you, Maria. Thank you, Otávio. Now, Catherine Elgin had raised a hand very early. Let's see her question, then I go back to the list. Please, Catherine.
Okay. One of my major worries about the way you approach this is it seems to me you have a perfectly fine objection to Walton, but the objection holds also for Walton as a theory of literary fictions. The prop rigmarole just doesn't work.
Yep,
so
I agree. I agree with that.
If we leave that out, then the question is, might it be the case that literary fictions are much closer to what you're talking about than you sketched the view as saying? Because I think they actually are. I think that you could do the same sort of inferentialist story that you give for, or at least, one of the families that you talk about, and say that, yeah, well, in reading literary fictions, in reading War and Peace or reading the Fellowship of the Rings or whatever, we get certain representations and we draw inferences. And then the difference between the scientific case and the literary case would be the range of inferences is permissible to draw. So, for example, literary fictions are more open-ended, or the constraints on them are looser. We could say something like that. So certain associations, analogies, and so forth, you're at liberty to use them when you're reading Lord of the Rings, that you're not when you're looking at your Newtonian model, because the Newtonian model has more constraints. But still, the sort of fictionality story you've got is the same even for the literary case. And I think that's actually that's correct.
Yeah.
And it's also powerful.
Good. No, I agree with that. I think, yeah, my concern with Walton is indeed the artificiality, right? In putting this pretense and props in the middle.
I mean,
that sort of, yeah. And I agree with you that when we are engaging with fiction, genuinely lost into the story, right? We are at that point, we are inferring. We're trying to figure out what's being said, what follows from what is being said, how to make coherent certain claims that, and so on. And I think, yes, it's an inferential process. And with that, I'm perfectly fine, right? And I think there are important similarities with that. The worry is just in terms of, in the way that the fictionality approach invites us, is to say, well, now we need to think about the scientific objects themselves as fictional. And I think that...
Well, I mean, even there, you could tell a fictional story about real people. So you can have, for example, Napoleon showing up in War and Peace or whatever. So you can do the same thing in literature. And you could even do, a whole fiction where you say every protagonist was real, but the interactions were made up. And you can do all of that.
It's just that I think Napoleon in War and Peace is a fictional character. He's not Napoleon.
But now I'm going to give you the same argument back on you by saying, well, he's no more fictional than the point mass baseball, or no less fictional than the point mass baseball, because the question then is how you extract from the representation to the reality. And
exactly. But that's where the big difference comes in, right? It would be a mistake to say, oh, I know that Napoleon, has whatever feature. And so how do you know that? I read in War and Peace.
Well, we're mistaken in the same thing. If I said that I know that a baseball is a point mass, anybody who's ever tried to play baseball knows perfectly well it's not a point mass. I mean, you can be as bad at baseball as I am.
That's right. But the difference would be in setting up Napoleon and its behaviors in War and Peace, right? I think would be a mistake, right, to try to infer anything about the way the world is.
Okay, right? Let me now give you my counterexample, because I've actually got one. Schliemann found Troy. And Troy, actually, the city that Schliemann dug up, has the exact description in the Homeric poem.
Yeah,
and so he discovered something real. And he didn't say, oh, this can't be right because it was a fictional story. He said, oy vey, Troy was real.
I think that's a confusion. I think it's a similar confusion to go to London and say, oh, this is Baker Street, so Sherlock Holmes must have been wandering here sometime, right? And I say, no, it doesn't, right?
So you're saying that you cannot go you're saying you can't go to Turkey and see Troy?
Well, the question is this: is the Troy that you can see there, the one that is described in the Homeric poems? And I say, well, if you take Homeric poems as literature, then the answer is no. If you take them as a historical document that aims to describe the way that the world was, well, then it's no longer literature. Then you're taking it to be something else. But the moment you do that, then you're changing completely what the content and how you're going to interact with that work. And I think that's the important difference between fiction.
I think we just disagree about this. And I think that there's just a continuum of cases from something like the Fellowship of the Ring through more and more and more realistic fictions. And if it turns out that you can just walk into Troy and it's answers to the description you find in the poem, you don't want to say, what an amazing coincidence.
Look, it's possible that Homer was motivated by things he saw in the world. That happens all the time. My point is the moment that he put that in a poem, right? And it's not meant to be a historical description of the events, then he's doing something else. at that point. It's something, and I want to say, I see if you think that there is a continue, you want to tell the story you do. I think it's not a continue. It's a difference in kind, right? I think fiction is not meant to tell how the way the world is. It may tell you how the way it could be. The world could have been that way. It may give you modal information about things, right? But even there, I think we need to be very careful, right? Because I think it's giving us a certain mode of reflection about the world, which is fundamentally different, I think, what a scientific model is trying to convey, right? So that's why I think there is a difference in kind here. That's why I don't want to...
Where do you put philosophical fictions? Candide, something like Rousseau's Emile or the Platonic dialogues, or, what do you do with them?
Well, it depends, right? Because I think if you're going to emphasize the philosophical part or the fictional part, right? If you think that what Plato is doing, right, in the Republic is describing just, look, this world that doesn't exist and he's just sort of describing it, it's a piece of fiction. If you think that, no, he's just giving you a manifesto, right? He's telling you what you have to do or you ought to do if you want to have the good and have philosophers guide in a wise way the world. So those are very different readings of that document. I don't think the document per se would settle the matter about how it's going to be read. I think that's because, these are just words, right? You may read a historical novel and think, oh, this is actually a history, right? So I don't think it's in the content of the work that you can draw that distinction. So, but it's in the way you are actually extracting the information, right? So, and I think Plato's dialogues is significantly ambiguous in that way. You can read it, for example, the way that Popper read it and said, oh, this is this guy who's trying to convince us and move us away from a free society. He took that to be a manifesto. Right? You can read as a piece of literature, Greek literature. Here's Plato meandering and reflecting about justice and the right and the good, and offering them in a vivid, live way that we would experience if we were actually talking with Socrates in the Agora, right, face to face. That's a different way, right? And the work itself, I think, doesn't settle the matter one way or another. But you cannot take it as being both. You need to make a choice here. And once you make a choice, you decided in one case or the other. Right? Again, look, that's the issue. If you have distinctions, well, then they will matter. They will settle things in certain ways. Of course, if you don't have, and of course, part of your holism is exactly to say, look, those things are in a continuum here. We cannot draw those lines. If you don't do that, sure, I think I can see why you wouldn't want to go there. But I'm not a holist, right? I think there are some lines here that I think we want to draw, right? And I think fiction is one of them. So that's why. But it's interesting. I would not have. In fact, I've written about this. I think we can make sense of mathematics in a fictional way, because then there's no expectation that there are any objects whatsoever anywhere. So it won't make any difference. So I think my worry here is fictionality of scientific models, because the modality of engagement with these models is one in which we're going to, again, try to tinker with them and get something about the world at the end with a lot of work. So, and I don't think mathematics, even in principle, could provide us with that, because it's describing things that could not exist in the world, abstract objects, right, on a certain interpretation. So you need to interpret the formalism in order to get anything empirical, but then it's no longer the mathematics. So, well, at least that's, my modest way of carving up the terrain. So,
Okay.
but thanks, Kate. Those are great points. So,
thank you, Catherine. Thank you, Otávio. Now we have the final question by Bruno Coelho.
Thank you, Otávio. I will more close because I use my Bernard's phone. I want to hear thoughts on Roman's most recent account of scientific representation. It is apparent it avoid the problems of the pretense account. And I want to hear more about that.
Bruno, I didn't hear the beginning of your question. Whose account of scientific representation are you referring to?
By Roman, the Roman Frigg.
Oh yeah, no, yeah. So you have he has an extremely elaborate and sophisticated account of scientific. In fact, in a way, in the paper I was talking about, it's just half of his project. It's the first half, right, where he's considering the nature of the models, right, and the fictional content. Now, the second half is the connection between the models and the world. And that's where the his Decky account of scientific representation will go, right? How the models will connect with the world. And he has a whole book, right, that came out last year. In fact, in the series I added in the Synthesis Library. I think it's a terrific book, right? And now I've been discussing with Roman about those things for years now. I find his account extremely interesting, but on the other hand, also there are too many moving wheels there. I think you can do with less. I'm a nominalist. I like to do things, for land, sort of desert landscapes with few, details. I want to tell a story about representation as scientific representation, something simpler. Part of that story is in my book with Stephen on applying mathematics, right, where we tell a story about how we connect models with, particular models that have mathematical content in it with details of the world. And that's something far simpler than what Roman has, in part because I think the complexity of the representational practices in science are not with the notion of scientific representation. The complexities are with the phenomena we're trying to represent, right? And in the maneuvers that we need to do in order to figure out how they represent. So I think what happened is Roman up front, all the moving wheels to try to account for all those things that I think several of them are to be accounted by the specific models that you are considering, not for your account of representation. So I have a slightly different, I hope a simpler story than his, right? So, but I think it's a really interesting and illuminating story, right? So, and in a way, the complaints I'm making to his account, he's going to say, well, I can answer some of them with the Decky, right? By the way that they connect. But I want to say, yeah, but then don't make it so fictional, your models to begin with, right? But that's a great point, Bruno. There is, of course, a lot to be said about that, and I highly recommend his book, right? And but also take a look at Kate's book on True Enough, right? Because that's also, I think, it's a really interesting way of thinking about those models. And I think I want to, as the note at the end of my talk, I want to incorporate the insights in my own sort of framework. I think a lot of the points Kate is making about the connection between models and the world can be accommodated in the partial structures framework. So, but I think the complexities, again, they are there, the way that she presents are also in the phenomena you're trying to understand rather than in the account of representation you're offering.
Okay, thank you, Bruno. Thank you, Otávio. So thanks. Let us thank our speaker again. Thank you, Otávio, for this wonderful talk.
Thank you all. Thank you for the great questions. And yeah, so and I really appreciate all the feedback and your reactions. So and
really nice. And we meet again tomorrow. Then we start our sections tomorrow in the morning according to the schedule. So don't miss it. And perhaps there's still people discussing this talk in the Gather Town. So if people get there, they will find more and more people discussing. So good night, everyone.
All right.
We are ready. Bye-bye.
Bye-bye. Thank you all.